World and kind of what are the top themes this year. This is our second H2O World. Last year, we were talking truly about the technology, truly about how the tools are being used by our customers, early adopters. Now we have a wider range of customers, so you'll see a lot of different talks. The core theme of the talk is that data science is actually become a truly team sport. You have data scientists, engineers, and data engineers and developers coming together to build smart applications and data products. So you're going to see a lot about those talks in different themes, different tracks, today, tomorrow, and the day after. How does culture impact your ability to build and deploy data products live? And how do you take insights and operationalize those insights from your data that you have? Data is your ultimate asset. We're going to talk about how open source actually breeds courage. We have learned so much from our own open source. And we're going to talk about our stories and stories of other customers who have adopted open source, moved from proprietary stacks to much more freedom and courage and ownership for your own stacks, for your own problems. And we truly believe that every generation needs to invent its own stories, its own math, because our problems are our own. And you cannot solve them with the thinking that was 100 years ago. You can't solve them with the thinking even 10 years ago, because the world is changing at a pace that has never been before. So you got to own the problem of today, solve it with the tools that are available, latest tools that are available today, in the context of the problem you're solving. So you're going to see a lot of that discussion in different venues today and tomorrow. There are about 80 talks, and only so many hours in a day, right? So you will miss some talks, but don't worry, there's live streaming. All talks are recorded and live and available. But the fundamental theme of this H2O World, we are here because of our community. Community matters to us. That is the number one reason we are doing this event. The number one reason we are all coming together is you guys give us courage as much as we give you code, but you guys give us courage by adopting our code, by adopting our culture. And the culture clashes we see now in a data science versus a data developer that we see today on a daily basis that leads to innovation. Clashes lead to innovation, right? On the divide, cultural divides where you see innovation, that's the same innovation is what gives us the courage. And we get feedback from our community continuously. And code is nothing but a conversation with customer, right? Our code, H2O, is a conversation with customer. And we think of this as a continuous feedback. We want you guys to participate. There's several open mic sessions. There's one at lunch where our customers, users can go on stage and rant about the product all the time, right? And talk about what they're missing, what they need, right? There's a Bool, is a space for developers to hang out and add more stuff to the product, as well as give us feedback. There's a hackathon going on as well. And the great product that we are talking about is actually a summum of a million lines of commits that have happened, tons and tons of commits that have happened, and hours of thinking that's gone into before us. All the math that was invented for the last hundreds of years is codified inside H2O and is extensible. All the systems engineering is extensible. And that's kind of what leads me back to the core of what we do. We are a product company. We build new products. We're going to announce a lot more stuff as we go, part of the rest of the talks. But at the heart of what we do is a fast modeling engine. It's the world's fastest, scalable, parallel distributed machine learning platform out there. And as it's evolving with no worry about what APIs we use, with no worry about what data sources we use, we are focused on building a very distinctive machine learning platform that can go embedded to where you are using it, embedded to where you should be playing with it. We called for the special effects today, and that's rain, right? H2O is the number one missing piece in California, right? And last year, people asked me, will it rain? It was about the same time. And I said it won't, and it just resulted. This time people asked me, will it rain? And I said, it better rain, because that is the biggest special effects we have. And talking about that, I'm going to leave with one final thought, is that you need to get wet today. It's a guarantee. You need to get wet today. If you want to get this yellow sticker, which is install it on your laptops, it's a hands-on, full day of hands-on stuff. So you need to get your laptop wet with H2O, right, sort of. And so there are 4 stickers that you get if you install H2O, install R, Python, and have the data sets ready to play with it. I'm going to talk, so how many of you have already installed H2O before? That's awesome. So we don't want to bore you with the basic H2O details. I'm going to set up our advanced, what have we done in the last 1 year since those who have attended H2O World before. So the last 1 year, the product has gone through tremendous change. We actually rewrote the entire product and have several interesting new things. And I'm going to introduce our chief architect, Arno Kandel, to come on stage and present the things that we built, both on the algorithms. And then Cliff will introduce on stuff we have done in R, Python, and Flow shortly thereafter. So welcome. Welcome to H2O. Thanks for being here. A round of applause for the community and the people who have put this together. Thank you.
Yeah, thank you all for being here. It's been an amazing year for us. It's been a joy to work on machine learning, which is getting harder and harder, and giving the people the tools they want is really a joy for us. So if you look at H2O 3 in comparison to H2O 2, there's a lot of things that have changed. We rewrote the entire core in Java from scratch. We added a new front end, this Flow user interface, which is a notebook and can do a lot more than just a notebook. We added schemas and stuff so that developers can embed it in their applications. We have faster R, faster, newer Python clients that now everybody can use their favorite scripting languages, sparkling water, Spark integration. All that stuff is native to us, basically. We have all the tools in place to do this work, and we've done it. So you'll be able to reap the benefits now. And of course, there's more than just these tools. There's also the algorithms on top of these tools. So there have been new algorithms like the generalized low-rank modeling, brand new out of Stanford by our advisor, Professor Stephen Boyd, already implemented in H2O. GLM got faster, new solvers, and there's a lot more. There's grid search for all the algorithms. In R, Python, Flow, there's n-fold cross-validation, there's early stopping, stochastic gradient boosting, all different distribution functions for insurance space. If you want to predict the claim that's being paid out, it's not necessarily a Gaussian distribution. So there's all these little things that we added. There's sparse handling for deep learning, auto-tuning, multinomial GLM, scalable scatter plots. If you want to visualize your data and you have 100 billion rows, you want to quickly get a 1,000 by 1,000 histogram scatter plot that you can do now in H2O. And we're working on big joins. It's right now in QA. So you'll be able to merge 2 tables that are both too big to fit on any node, 10 billion rows or more. Now we do a quick demo of early stopping with deep learning. For that, I open up the web API, which we call Flow. And you can see I'm parsing a file here. It's called Higgs, 100,000 rows. It's a Higgs boson particle data set, already parsed in a second. I'm splitting that frame. That's on my laptop, by the way, into 75-25, and I'm going to build a deep learning model on the 75% of the data, and I'm going to hold out the 25% as validation to see how well I'm doing on that model. And this is the old school model, just like it's always been in the last year or so. But just recently, we added early stopping. So what does early stopping mean? Early stopping means that you can build the same model in less time. I'm going to start the same model again, but here I'm adding these new features here. Stopping rounds of 3 means for 3 scoring iterations, if the model does not get better for the AOC metric that I specified, and it doesn't get better by at least 0.1% relative improvement, then I'll just stop model building. Okay? So basically, we measure the convergence, and you have full control over this, which metric you want, how many scoring iterations it should not improve, and what's the improvement that you're looking for. And it's also doing a simple moving average over the first few scoring iterations. So if you specify 3 rounds, it will do a moving average of length 3. So it's all nice and smooth. So let's see the model that already should have stopped after 15 seconds here. And let's see what it looks like. It has an AOC of 80% on the training metrics, AOC of 79.5 on the validation metrics, and you can see that it stopped early. It just flatlined here. This is the validation metric, the orange one. Blue is the training metric. As soon as it flatlined, it stopped. That's all automatic, because I didn't say it should stop at 26 epochs. I said it should stop whenever it's done, and I specified way more epochs here. As you can see, epochs, I say 250, but it didn't have to go there. In the old case, it would run for longer. It would run for 1 minute, 20 seconds. And I would get the same model in the end. Also about 80 AUC on validation, but it would take much longer. See, it would run all the way to the 250 epochs. So you have now full control to say, I don't want to see this flat line tomorrow when I come back to see that my model has actually flatlined, right? I'd rather have it stop and run something else. So this is especially good for n-fold cross-validation and grid search. In n-fold cross-validation will actually, these n models that you're building to cross-validate your model, they will all stop early. And then the point where they stop, they will communicate that to the main model that runs on all the data. And that main model will then use the average stopping point of all these cross-validation models. So you'll get the best model back as a user. And you say, give me a good cross-validated model. It will actually give you a good model, and it will tell you what's the holdout accuracy. So you get both flies all with one beat, as we call it in German. So this is a pretty exciting stuff, and there's way more. Today, you'll see a lot of talks about the technical parts of H2O, the tutorials. So make sure you have H2O installed. Then you earn yourself this yellow sticker. And once you have R and Python installed, you're able to roam around in the land of H2O. And the data sets are also on the memory stick. The pink sticker is kind of obvious once you have the memory stick. So everybody has a memory stick. Everybody has a laptop. Everybody has a power supply. You're all good. So Vinod will come up next and then walk you through these installation details. If you have questions, we have people around that will help you with that. And see you later for more talks. Thank you.